We're good. Good space one.
Alrighty, so we are Group 7 with the 17th engine. I'm Dylan Berryman, and my part was the camshaft. This is Paul Smith, and he had the crankshaft. Andre Sanchez had the piston, and Nick Naran had the connecting rod. So to start off, we'll start off with my part, the camshaft. To create the gear, I used the gear function in the SolidWorks toolbox. In order to design the gear correctly, you actually have to find the pitch angle and the diametral pitch of the gear. Those are found by measuring the pitch diameter divided by the number of teeth, and then the angle is measured. It's the angle between the teeth. And then I moved on to the circular extrudes. The extrude that is closest to the gear is actually extruded through in order to fill the hole that is in the gear, and the other two extrudes are just put on top of it. So then I move on to making the lobes of the camshaft. The lobe is actually, the origin is the same with the central origin of the part. It's just a semicircle that's tangent to both of these straight lines, and as you'll see later, the tops of it are filleted. It's also got a small thickness right there on the other side of the gear and another cylinder portion that leads to the first lobe. So then with the rest of the part, as you can see, the second lobe is actually vertical, whereas the first lobe is 10 degrees below the horizontal. The rest of the part is just more cylinder shapes, with the second lobe being the exact same as the other one, just in a different position. So to the final part, I added all of my fillets that are in between each level and each space, and the fillets on top of the lobes. And on the ends of both camshafts, there are two chamfers and a cut through the top part of the gear. So I'm going to move on and hand it off to Paul with the crankshaft.
All right, I had the crankshaft, and just as Dylan, I also started with the gear. So we did it exactly the same to find the pitch angle, and we used the gear tool, or I used the gear tool to discover and to draw the gear, and then I had to extrude all that, the actual gear drawing that it gave me. And then next I moved on to the revolve feature. I drew a part of the feature and then revolved it 360 degrees. Beyond that, I drew multiple planes and then cut other sections to define the counterweights. Beyond the counterweights, I drew the journal for the connecting rod. So on the planes I had described previously, I drew two circles, and then the actual journal in between that the bearings connect to, that attach the connecting rod to the crankshaft. And after that, I extruded the circles in the opposite direction to define more of the counterweights that I would therefore later on I would cut it, and then I began to cut it. So to cut it, I had to find angles in an indirect way, had to measure distances from other parts of the part and draw them that way. I drew planes, and on the planes I drew the image that I wanted to cut out, and then I extrude cut on the right and the left. The left side of it was more difficult. I had to cut, revolve, and add fillets to other sections of it to allow the oil and all that to rotate around the crankshaft. And in the end, I had to finalize my part by adding all the fillets and other stuff. I used the cut wizard feature, or the hole wizard, to do the hole in the end of the crankshaft along with the threads on the crankshaft that allow a nut to be attached. I drew another plane in SolidWorks to cut the keyway that attaches it to, that allows the flywheel to attach, or I have no idea. And this is what it looked like afterwards when I was all finished. And next is the piston with Andre.
Okay, so I drew the piston and pin, and that's what it looks like. I first started with a revolve base. I drew the outside diameter of the circle, then revolved it whatever distance I measured. Then I drew another circle on top of that one to cut it in to get my inside surface. And then I also had to use a revolve cut to do them 3 sections that you see that are cut into a circle. Then I had to do the wrap feature to get those 4 cuts that you see inside of there, and I had to do that by using arc length. And Then I also measure the distance of that circle. I measure the distance from the outside of the circle to the first surface, and that's how I got where the circle was located. Then this is what the inside looks like. I had to draw those areas that you see that are cut into the circles are not straight areas, they're in the angles, so I had to find those angles by indirectly solve the distances between each other. And then at the bottom of those surfaces, you see this a little on the angle, so I had to measure the depth from the top of the cylinder to the bottom of that area to find the area. Then I also had to draw a plane to draw that tall feature that you see under, which also is on the same diameter as the other side, so I just did one cut through all. Then those small details I just had to measure throughout my measuring. This is what the piston looks at the end, assembled with the pin inside of it. And next is my friend Nick with the connector rod.
The connecting rod, we started, well, this is the finished product with the assembly at the top. I started with a mid plane throughout the middle of the part, sketched it, and then extruded it in both directions with a slight draft angle, which is what the little line here is for. On the right side, we have the inside cuts to the little I-beam, basically, between the two circles. And I just created that with 3 different widths, and then just cut it from the giant block that I had started with. After that, I added a little details with the little outer face right here, this little notch, and that's on both sides, as seen over there. I added this little cylinder bit, which is for the screw that connects the top part and the bottom part together. And then I add this little circle. After that, I finished up with a little bit of details, made the hole go through the entire part for one screw. On the next face, I made the other screw hole. And then in the middle, there's a hole there that goes through the part, but not through the top face, which is why it won't be shown at the top. I also added a fillet to the edge along the back and on the inside of the I-beam. And then I extruded the circle again to fill up the top part. So the bottom part was previous scene, that's where I finished that. And then from there I just created the top part based on the bottom part's base. And then I just came up with the circle for the two screws, came up all the way to the top. And then I created the little valley at the top with a cut sweep that goes from edge to edge, and then that created the little outside border right there. And then on the far right, you can see there's a little cut, and then that's the top part right there. After that, I use the same part to create the prototype, which is here. It's the same part, just a few modifications on it. First, the group numbers. And then on the side, we created little triangles to help improve strength of the part and then lower the material cost. So there's 4 triangles they grow a little bit bigger, but they're all proportional, I guess. And then I made the 2 diameters a little bit bigger for the pin to fit in smoothly with the 3D printing. And then there's the top view of the numbers again. I did make the little cut less of a detailed part because I didn't see much point in having various curves instead of just having one giant curve. And yeah, that's it. Stop there. Wow, barely 9 minutes.